Hi everyone, so today we're looking at new associations. Before we talked about associations with categorical data, today we're talking about associations with numerical data. Okay, quantitative is the fancy word. And so before in our last unit we looked at when we had categorical data, in order to figure out if there was an association, we saw, hey, I got to look at the conditional distributions. In this unit, it's a bit different. So let's explain how this is going to go down. So when we are analyzing, first off, let's just talk about this. Highlight here that we are talking about relationships and associations now with two quantitative variables. Okay, that's the different part. The way that we are going to look at this is we want to look for a pattern in the data. So how are we going to do this? What you are going to do is you are going to make a scatter plot. Okay, scatter plots are going to become our best friends. And when you make your scatter plot, remember from last unit, we have our explanatory variable down here on our x-axis, and on our y-axis we have our response variable. Okay, and somewhere in here we're going to have a scatter plot. So let's kind of talk about what this looks like. So the first thing that when we are looking for patterns with our scatter plots, okay, we are going to have a couple different options. The first one is that our scattered plot is going to look kind of like a line. It could be, a positive relationship, it could be a negative relationship, but we might have some data that looks like that. That's linear, right? Okay. Or we might have something that our scatter plot right here where it might look like a curve. So let's just say maybe it looks like that little rainbow action. Or maybe our stuff it's a cluster graph. Okay, so maybe everything is just in a ball right here in the middle or something like that. Or maybe it's just random scattered. I don't know why I drew that so big, but maybe it's just kind of all over the place. Okay, and so these are kind of some different options when we make scatter plots that they could look like. So first thing you're going to do is identify the form. Okay, second thing is you are going to identify the strength. So something might be kind of sort of linear, or it might be very linear. So you would say, oh, that's a very strong linear relationship, or it is a very strong curved relationship, or if it's not, maybe you say it's kind of weak. Okay? Besides saying the strength, we are also going to want to talk about the direction. And let's just think about this one, for example. This one, we could have a linear relationship like this one right here that is positive. Do you see that? As one goes up, the other also goes up. Or we could have a relationship that is negatively related. So as one goes up, the other goes down. Okay, so as I increase these values, my y values become smaller. Okay, and sometimes it doesn't have a direction, like this blob that doesn't have a direction. Okay, something else that you want to point out that could happen is sometimes you might have these other outlier points, okay? And so that's something that you need to address. And so what is an outlier? We've talked about this year, but there's something a little different here. So outliers are points that stand out in a vertical direction. Okay, let's think about what this looks like on a graph. So let's just go back to the linear example. If we had some linear data, and then it said that it stands out in a vertical direction. So this right here would be an outlier, okay? This down here would be an outlier, okay? So it's an unusual y value considering its x value. So here's the x values. You would figure that it would fall in line with these, but it doesn't. And let's talk about a high leverage point. Okay, high leverage points are a little bit different. This is when something is standing out in a horizontal direction. So if we had something that looked like this, okay? Imagine we still have a linear set of data. Looks like that, and that's where it stops. Well, these are potential high leverage points. One would be this. This would be a good high leverage point because we'd say, hey, way out here, look, that makes our relationship even more linear, right? It's standing out in a horizontal direction. And this could maybe over here be a high leverage point. Still sticking way far out from everyone else though. it is horizontally in a weird direction, or maybe way up here. But that wouldn't also be what would be expected. Those are all high leverage points in this example. So this is because they are sticking out in a horizontal direction away from our data, whereas these other ones, they're kind of in range with the rest of them, but they're kind of sticking out in a vertical direction. Okay? And so this would be that we have an unusual x value. They're further than the rest of our data things. Okay, so now let's talk about putting all these things together. So when we want to write about in a relationship, so now we've talked about all the little components, all we're going to do is put these together. So you're going to talk about, this was the first thing we said, the form. You're going to talk about the form of the relationship. Then you're going to say the strength and the direction, and you're going to talk about outliers and high leverage points, and always include context. Context never goes away. Okay, so pretty much everything that we have on this page right here is got to go into figuring out, hey, do we have a relationship between two quantitative variables? So let's see an example of this in action, okay? Let's look over here. So here we have, there's a caveat that I need to talk about first because we haven't talked about it yet. Okay, here we go. This first one, it says, a study on test results in the hours spent studying had a correlation of R. Okay, this we don't really know yet. I'm going to talk about this in a little bit. This is just showing you, this shows you how strong of a linear relationship. I don't think that's really quite English. It is. But I'm just saying the closer this number is to 1, the more strong or the more linear it is. Okay, if you have an R of 1, you have a perfect line. Okay, so this is saying it's just pretty linear. And this only works when there is a linear relationship. So that's what that's saying. So let's go back to what we just talked about. So here we have a scatter plot that they gave for us and a residual plot. We'll see where that's important. But the scatter plot is right here. Okay, and so first thing from our sheet before, it says at the very bottom, in order to write about this, we need to say the strength, the direction, and form. So I would say that the data has I'm going to say this looks pretty stinking linear if I draw a line through there. I'm going to say a strong, positive, linear, you can say association, a relationship, whatever, association. And besides saying that, we need to mention outliers or whatever. And so here, if you look, these are in step with the rest of the data, but they are further away. So I'm going to say they have a strong positive linear association with two seemingly, I don't know if that's how you spell that, seemingly outliers at, I would say, about 135, this little bugger right here, 135, and then this guy, I'm going to say that's, I don't know, 0.3 and then 100. It's a little less than 100. I say 97. Okay, and then I'm still not done, because right now I've done 3 things really good. I have said we have a strong, that's one thing. The next thing we needed to say was direction. We needed to say form. We got all of these good things, and we even mentioned outliers. That's great. Okay, but we're still not done. It says over another thing that we need to say what we learned about the relationship in the context. So what am I learning about this? It looks to me that the longer the hours of studying, the higher the scores tend to be. And so that's what I have learned from this. So I'm going to say just exactly that. The longer the hours of studying, the higher the test scores tend to be. Okay, I'm not saying they are, I'm saying they tend to be, and so that is like in a relationship thing. So those are kind of our first three parts. So first part, give strength, give direction, give form, talk about outliers or high leverage points, then make a conclusion about it. All right, let's do one more of these things. Here is the next one. The next one says the data below has a correlation coefficient of this. Again, we have not talked about this rate yet, but the correlation coefficient, this right here, is how strong of a linear relationship we have. Again, this is not linear. If you look at this, this is, to me, this doesn't look very linear. So, not linear, useless. And you'll see this later. This can be very helpful. This would tell us how strong of a linear relationship we have. But since this isn't linear, this number doesn't really tell us anything. Okay, so below we got this data. We have speed and gas mileage. Okay, so let's look at this. So to me this appears to be curved. That's the form. I have a curved form. It seems pretty like a strong form. I can clearly see that arch. And this little point over here, he's not really with the rest of them, right? Do you notice that? Here's all the other ones are clumped, and there seems to be a gap. And this guy seems to kind of be further out than the rest of them horizontally. So that kind of leads me to think it's a high leverage point. Okay? And I also noticed that it's increasing, right? As my speed increases, my gas mileage also increases up to a certain point, and then it decreases. So I'm going to want to mention all these things. All right, so let's talk about this. So I would say, here we go. I would say there is a strong curved association that is positive. It's positive until about 50 miles per hour. So it's positive up until 50 miles per hour. Then it turns negative, right? Here's a positive way, negative. Then it turns negative after, you could say after 50 miles per hour, but after you get to this point, it's positive, then after it's negative. Okay? And then so we've mentioned our strength, right? We've said it's strong. We've said the direction. We've said it's positive and negative at certain points. And we've also said that it's been curved. So far so good. Form, strength, and direction. The other thing we need to mention is outliers or whatever. So there's no outliers, but this is a high leverage point. So I would say there appears to be a high leverage point at I would say maybe like 105. Okay, and besides that, we have now looked at our graphs, and now we have to make some sort of conclusion about this relationship. So I would say, okay, as the speed increases, so as speed increases up to 50 miles per hour, the gas mileage tends to increase. And then I would say as speed increases beyond here, the gas mileage tends to decrease. So I'm literally going to say that. It's going to be a whole thing. So here it goes. As the speed increases up to 50 miles per hour, the gas mileage, how do you spell mileage? Mile with an H on the end. Mileage tends to increase. It tends to increase, and then I would say as speed increases beyond 50 miles per hour, I would say that the gas mileage tends to decrease. Done. It's beautiful. That's all we got for this part.